reach the stage in which we will study the second derivative. So I go back to the first derivative, which is right here. I'm going to copy it because I want to continue. Not in that form. I want to copy it as 15x squared minus 15x to the fourth. And then I will find the second derivative. Can anyone give us, who I haven't heard from everyone yet? Carson, Derek, Trey, Josh, anyone? Excellent. So this is basically nothing else but 30x and 1 minus 2x squared. So when we factor out 30x, very ugly, and I'll show you why it's ugly. 0, so x equals 0, 3 solutions. And I have 1 minus 2x squared equals 0. Of course, that I move 1 and I get x squared equals 1/2. But when I take the square root, I have plus or minus the square root of 1/2. And it crashes with all my points, and I have to build my graph, my table again, because they're so close to each other. I don't have to, but I will. So x equals plus or minus 0.71. I don't want to squeeze 0.71 here and here. You don't have to do that. You can probably erase and make more room in there, but I have no choice. I will have to remake my table. It will only take a blink, I promise, but I like room between those numbers so I can explain what I'm doing. So now, since I have all numbers, I have negative infinity, negative 1.3, negative 1, negative 0.71, and then 0, and then 1, no, 0.71, and then 1, and then 1.3, and infinity. Okay, so this was 0 here, 0 here, 0 here, positive, negative, and then we had 0 here, infinity, negative 2, 0, 2, 0, negative infinity. So this was down, down, and then up, and then down. No, it was up, of course, and then down, and then down. Good. Okay. Obviously now I need these two values. So I go back to the function. Like 5 pages ago, the function was, I'm going to put it in, it's easier for me. So 5x cubed, and then minus 3x to the 5th power. And I want to plug in, what do I want? I want the square root of 0.5. And I got 1.2. 1.2. And the other one, the function is odd, so the other one will be negative 1.2. This one will be negative, this one will be positive, because I plugged in the positive one. Okay. So here this was 0, here was 0, and here was 0, because I had x equals 0 and x equals plus or minus 0.71 for the second derivative. Now I need to finally study the sign of the second derivative. Before that, I don't want to forget, what type of point is this? What type of point is this? Let's identify it. Say it again. Very good. Local min. And what type of point is 1, 2? Very good. Perfect. So we established that. Of course, the rest are, these are the x-intercepts. So now I want to study the sign of the second derivative. So I'm going to copy here. The second derivative was 30x 1 minus 2x squared. So I have 1, 2, 3, 4 intervals. In this interval, I want to plug in negative 10. This is negative, negative, and this will also be negative, so positive, which means the function opens up. Here this is difficult a little bit because I have to put in negative 0.1. So this is negative, and this will be positive, so that's negative. Here I put in 0.1, so that will be, this will be positive, and this will be positive. And when I plug in 10, this will be negative. So the function, we say it holds water, it doesn't. It holds water again, and it does not. Now, final question before we graph. What type of point is this, this, and this? And the reason for my question is to look at the second derivative. It changes sign. At this point, this must be an inflection point. From the function opening up, all of a sudden it will open down. So this is an IP. Also at 0, the second derivative changes sign. From opening up, all of a sudden it changes and opens up. From opening down to opening up. So this is another IP. 0.71, 1.2, the second derivative at this point changes sign again. From holding water to not. So that's another IP. And now we're finally ready to graph. I do not need any information except my table. Everything else will be a waste of time to look at. This is all in here. I'll start with the points I have. That's my first step. I have negative 1.30. Since everything happens between negative 1.3 and 1.3, I will take, and it's not too high or too low, so I'm going to take a big unit. So I'm going to say 1, 2, 1, 2, 1, 2, 1, 2. Okay. So the first point is negative 1.30. Maybe I should use a different color and use this. Then the next point is negative 1, negative 2. Negative 1, negative 2. Then my next point is negative 0.71, negative 1.2. Okay. Negative 0.71. Negative 0.71, negative 1.2. Then the next one is 0, 0. Then the next one is 0.71, 1.2. Then the next one is 1, 2. And then the last one is 1.30. Before I look at the table again and graph the function, I want to refresh your memory on what is called symmetry, because that has to be calculated or determined for any function. If f of negative x is identical with f of x, it's a situation like this, like with x squared, and the function is even. That's one type of symmetry. And here's the second type. If f of negative x is the opposite of f of x, then it's a situation like this. So this was x squared, and this one is x cubed. And the function is odd. So the function that we are looking at is this. And if I find f of negative x, you will see we replace x by negative x everywhere. 5, negative x to the third, and minus 3, negative x to the fifth. Then this is 5 times negative x to the third, and this is minus 3 times negative x to the fifth, in other words, and this is negative 5x cubed, but plus 3x to the fifth. And this is not f of x, but it's the opposite of f of x. So the opposite of f of x will be negative 5x cubed, true, and positive 3x to the fifth. So the only thing that I need to put on the side of the table is function is odd. Odd functions are symmetric with respect to the origin. Symmetric with respect to the origin. This is symmetric with respect to the y-axis. Symmetric with respect to the y-axis. Knowing that the function is odd, I really don't care for this side to look at the table. Once I graph this side, I will reflect it from the third quadrant to the first quadrant. But that's okay for now. Let's look at the entire table, because this is the first graph we have. Okay, so here's how we look at the table and graph the function. Coming from positive infinity to the x-intercept opening up, decreasing. Continuing to decrease to -1, -2, where it has a local minimum. Continuing to, so now it's, where am I? Positive. So it's increasing now to the first point of inflection, still opening up, increasing to the point of inflection, where it changes concavity, and it continues to increase to the next point of inflection, opening down. There is an inflection point. Again, I don't have to look. I can just copy everything on the other side, but that's okay. So now all of a sudden it opens up. It's increasing to another point of inflection, where it changes concavity, and it continues to increase to the local max. At this point, it reaches the local max, and it continues to decrease, crossing at 1.30, going to negative infinity. And this is the graph of 5x to the third minus 3x to the fifth. Any questions? We're going to do this for a while in this class. At least this class and next one. This session and next session. And please tell me what you would like to choose next. Feel free to choose any other problem that you would like to look at and graph from the beginning till the end. Now this